Hi, folks. If you're just joining us, we're going to take a minute and let folks join. I'm a little unfamiliar with the platform, so I'm looking for where the attendees are. There we go. So we'll hang out for just a few minutes here, or just a minute or two, and then we'll get going. Well, I think that's the 60 seconds, John. We can tap dance some more, or we can get going. It's up to you.
I'd say let's kick on, Duncan.
Let's do it. Awesome. So welcome, everybody, and thanks for joining us. If you're not familiar with Tabnine, welcome, especially. Tabnine is the secure enterprise-grade AI coding assistant. That's what we do. We're built to run inside your environment, aligned to your standards, steerable, and designed for your real-world development at scale. That's what makes us a little different. We're different than most AI platforms. So we're org-aware, like I said. We know your docs and we know your code. And we are steerable to your policies and enforce the way you need things done. Office hours, if you're new to office hours, sometimes we do live demos in these, and occasionally we cover broader topics and important topics like today. Today, we're going to unpack what it really means to be air-gapped, not just some marketing claim, but as a provable architectural stance. So real-world environments that are in defense networks, SCIFs, healthcare systems, financial institutions, any highly regulated industry. You guys know what air-gap means, but the problem comes with AI tools and the risks of data leakage. We'll talk a lot about that today. Silent updates, cloud callbacks, all these things aren't acceptable in an air-gap situation. And you'll see what breaks most SaaS AI tools and how Tabnine is engineered a little differently. To take us through that, we've got a rock star, John Feeney, our principal architect here. He's been here for a couple of years. John's going to walk you through the requirements of operating in those kind of air-gapped environments and be here to answer any questions at the end as well. So he'll show you how we built Tabnine to deliver code securely wherever you need it in the most strict environments in the world. John, I'll turn it over to you.
All right. Thank you very much, Duncan. Hi, everybody. Welcome and nice to meet you all. So as Duncan mentioned, we have a lot to get through, so I'm going to just dive straight into it. What I've done is I've basically categorized everything that I want to talk about with you today into three broad categories. So first of all, we're going to look at the business side of things. What are the drivers for organizations and enterprises to go with an air-gap deployment for their generative AI solutions. And then we'll follow that up with a look at some of the capabilities that you can expect as part of an air-gap deployment. And then finally, we'll get into the technical details when we look at the practicalities of all of this. And then we'll try and leave at least 15 minutes at the end for Q&A. All right, so getting straight into it then, let's look at the business imperatives. Why would you want to go to an air-gapped environment? Now, before I get into that, I do want to kind of have a quick look at the state of the nation, right? So where do things stand right now with generative AI? So as we all know, certainly AI is revolutionizing software development right now, and it's really changing the way we work, the way we think about work, and really accelerating everything across the SDLC. And there was a recent survey by Gartner where they've shown that for enterprises, the adoption of AI coding assistance by their developers is expected to reach about 75% by the end of 2028. And that's a huge increase and quite a remarkable number because, at the start of 2023, that number just stood at 10%. So that's a really phenomenal growth in this area, in this category. And, it's been really transformative for developers, AI. and it's really accelerating their software delivery cycles. They're reducing the time to market. And all of this is borne out by other studies as well. So there was one from McKinsey that shows that engineering teams, they can expect, with AI coding assistance, they can expect to see anywhere between 20 to 50% of a increase in their development and reduction in time across key tasks. So there is this revolution that's going on right now, and so generative AI has become a top priority for a lot of CTOs, a lot of CISOs, but it's also creating tension because for these decision makers, there appears to be this, almost an impossible choice. You either embrace AI capabilities and then accept security risks, or you maintain your existing strict controls and security protocols and forgo the benefits of AI that others are seeing. So, there is this perceived trade-off that needs to happen between speed and innovation on the one hand, and then security on the other. Now, in these next few slides, I'm going to talk about why there doesn't have to be this trade-off, right? And I'll show how, many enterprises are deploying to their own AI infrastructure, and in particular to air-gapped environments, with tremendous results. So looking at these business drivers, the first one of these is data. So data sovereignty, data loss. There was an annual survey that came out last year from Proofpoint. And in this survey, they interviewed a bunch of CISOs, and they found that 80% of these CISOs are concerned with customer data loss or loss of IP through generative AI platforms. And they also interviewed a number of enterprises, and they found there that 58% of these enterprises feel like that they're totally unprepared to respond in an event that data is lost. And they are right to be worried because over the last couple of years, there have been some notable events, data loss incidents when it comes to AI. So one of the more famous ones was with Samsung, where some of their employees uploaded meeting transcripts and semiconductor designs into ChatGPT. You had another one in last year with Slack, where researchers found that they could manipulate Slack's AI offering through prompt injection to leak data from private chat channels. And even Microsoft themselves, they accidentally exposed 38 terabytes of their own internal data when publishing their AI training data set towards the end of 2023. So, data does not just walk itself out the door. And the rapid rise of generative AI is amplifying concerns, quite rightly, I think, around human risk. As we all know, human error will always occur in all walks of life. And in technology, human risk, it really does remain a critical vulnerability. And so understandably, data privacy, data loss, these are things that are very much at the front of mind for many enterprises, and especially those that are operating in highly regulated verticals such as, government, finance, financial services, defense, critical infrastructure, and so on. And, we are in this era right now where cyber threats are also growing in sophistication and frequency. And so if you've got confidential IP or data, you need to start thinking about possibly an airtight data protection strategy. And air-gap deployments is often seen as the natural solution to these threats. And again, these threats are posed by not only external actors, but also internal actors as well. Now, another driver for moving to air-gapped is regulation and regulatory compliance. Now, depending on where you operate, for many organizations, an air-gapped deployment for their AI solution is not just helpful for compliance, but it's really the only option in order to achieve compliance. So there's a number of frameworks here, which I'll just go through very quickly. So GDPR, we're all familiar with. With GDPR, you need to know exactly where your personal data or where personal data is being processed and stored. With cloud AI services, your data could be processed across multiple jurisdictions. It could even be used for model training, even without your explicit knowledge. In GDPR, you have a number of provisions or articles, like Article 28, which requires a number of detailed processing agreements, but it's hard to guarantee compliance sometimes when you don't control the infrastructure. With an air gap deployment, you do have that complete certainty. The data never leaves your location. So moving on then to healthcare and finance, you've got like HIPAA, which requires that every access is logged, every transmission is encrypted. And importantly as well, if there are any breaches, they need to be detected immediately and reported immediately. So when you're sending protected health information to a cloud AI service, you're creating numerous potential breach points there and also expanding your risk surface greatly. On the financial services side, Basel III dictates that there is operational risk control and system resilience. And again, this is kind of difficult when your AI runs externally. There's a number of government and defense standards in there as well, which I'll just touch on really, really quick. So there's ITAR, which prohibits the sending of technical data to foreign systems. You got FedRAMP, which provides a framework, but for some of those classified requirements in there, it's really hard to achieve without an air-gapped environment. Then you have NATO and EU sovereignty demands, where obviously processing of data has to be local and has to fall under certain jurisdictional controls. Then you've got the EU AI Act, which calls, especially for high-risk AI deployments, it calls for physical isolation from external networks. And an air-gap design really helps here to comply with some of the strict requirements in the EU AI Act. So things like safety, risk management, and so on. And then finally, we have SOX, which requires that financial reporting systems and controls, that they are certified. And it's hard to certify with cloud AI when you don't control those systems. All right. So look, in summary, the regulatory landscape is becoming more and more complex with each passing year, and that's why enterprises are opting for an air-gapped deployment. With air-gapped, compliance isn't really a struggle anymore, but it's something that's architecturally guaranteed. Now, another business imperative here that I do want to touch on is cost. And this is something that's quite often overlooked initially. And it's something that we do need to bear in mind given how AI coding assistants are used today. So I want to explain what I mean by this by first taking a look at the evolution of AI coding assistants over the past 12 months or so. So if we kind of rewind to about a year ago, AI coding assistants were very much a human in the loop affair. So the developer would offload micro tasks to the AI coding assistant, things like, document my function or generate unit tests. And then we've evolved over the course of a year to where we've started to use agents, and we've made forays into agentic workflows. And so, we're getting away from AI as a monolith, and now there are agents. These agents are able to take on larger pieces of work. They're specialized at certain tasks, and they have a certain degree of autonomy. And we've progressed over the course of the year to where we are today and where we're going, which is what I call the AI engineer. And this is like a kind of a semi-autonomous or even a fully autonomous AI colleague that's able to take on much larger software problems and complete them from start to finish without any interaction from the human, pretty much. And they do this by orchestrating a collection of agents together. So all of this is to say that, in terms of token consumption, we've seen an exponential growth in the consumption of tokens as AI coding assistants have evolved. And so a year ago, a developer might consume maybe 500,000 tokens when they're doing pretty trivial things like refactoring some code or generating unit tests, to the point where we're at today, where even a single individual can consume upwards of 50 million tokens, while working on certain problems using agentic workflows. So, and what really nobody tells you until you find out the hard way is that, all of these failed interactions with models, they still cost, right? So you're still paying for those tokens that are going in and out. And, if you go online, you'll see there's a lot of people that are not happy with some of the cloud vendors. They've received big bills, unexpected bills, as a result of their agent related work. So what all of this means really is that even if you have a small development team, it can be much more cost effective to have an on-premise or indeed an air-gapped AI deployment where you control the hardware and you control the inference. Typically, it's somewhere between 3 and 5 times cheaper to host your own AI infrastructure and your own LLMs for agentic work versus using an LLM from one of the large model providers. Of course, there is this upfront cost in terms of hardware. So you got to have the GPUs, and then there's the ongoing operational costs. But what we're seeing, and this is borne out as well by online studies and articles, is that the break-even point usually comes after about 11 months or so, give or take. It really depends on the size of your GPU cluster, the number of users, type of work you're doing, but usually the return on investment can come with, in about the first year or so. So cost is an important consideration as well, and another reason why some enterprises are going to air-gapped and on-premise. Now, just to round this off, there's a couple of other points that I do want to touch on as part of the business need side of things. So there is operational transparency. So it's important in some cases to have complete visibility into every aspect of your AI operations. So, every prompt, every response, every decision. Sometimes you want that to be, accessible for audit, for inspection. And it's not just about compliance. It's not about just satisfying regulatory bodies, but sometimes it's about just understanding how AI is actually being used in your organization and then being able to optimize that usage. Strategic independence and flexibility as well. When you control your AI infrastructure, you're not at the mercy of a provider's roadmap. You're not at the mercy of their pricing changes or even service modifications. And if you want to switch from one model to another because maybe a more capable model has emerged, that's then becomes a reasonably trivial thing to do. It's a configuration change rather than, say, a migration away from a vendor. And all of this really translates into negotiating power as well. You're never locked in, right? Security architecture is important as well. With an on-premise deployment, you implement exactly what you need. So your security team maintains full control, and they're able to use tools that are familiar to them, and they're able to use established procedures. Availability is another benefit. With your own deployment on-premise, you can achieve 3 nines or even 4 nines uptime because you control all the variables. And also, you're not going to run into any surprise rate limits either during critical operations. And there's no throttling either during peak usage, right? You're in control of everything. And then finally, I think most importantly as well, there are those agentic features. So modern AI coding assistants, they use MCP, they use tooling to be able to provide autonomous workflows and to be able to perform actions on behalf of users, which is really powerful, but it's also incredibly risky as well if it's not controlled. So if you're the type of organization that needs full control over every API call, every database query, every automated action, and you want these things to stay inside your security perimeter, then on-premise or indeed air-gapped is going to be called for. You want all of the capability, but none of the exposure. So those are the imperatives, the drivers for moving to air-gapped. And what we're going to do now is we're going to shift gears and we're going to look at what you can expect in terms of the capabilities in an air-gapped deployment. So to kind of look at this, I want to begin by talking about the evolution of models over the past year or so. There's been really a fundamental shift in what's possible with these models. So I'm going to begin by talking generally. So I think the biggest thing that we saw over the last year is the emergence of reasoning capabilities in models. So that now they don't just pattern match, they're able to genuinely reason through problems and think about problems in very much the same way that a human would. They're able to break down complex challenges, they can think critically about the solutions to those problems, and they can leverage chain of thought processing to arrive at well-reasoned conclusions. And they're able to iterate on their work and improve on it if they need to. So that's been huge. Multimodality has been another capability that has opened up entirely new workflows. So now I can upload a sequence diagram to the model, and I can ask it to generate code from that diagram. I can also upload a screenshot that contains an error message and have the assistant help me with root cause analysis through that. Or, if I want to refactor a web page, I can upload a visual mock-up of what I want, and the model will be able to work with that. So that's been a bit of a game changer as well. Then there's also been this increase in context windows as well, which has been very important. So we've gone from like 16K tokens and 30K token sized context windows to now 128K tokens, and in some cases even up to 1 million tokens for some models. And what this means is that you can feed a lot more code and associated documentation into a single interaction and get, of course, higher quality responses in return. And again, I think probably to kind of cap all this off with probably the most important thing is the agentic capabilities that models now provide. So, these models are now able to they're able to invoke tools. So, they can instruct agents to use tools to pull in information in real time from external systems, and then have this context provided to the model. Models can also use these tools to perform actions on the developer's behalf, right? So interacting with external systems and automating many of the tasks across the entire SDLC. So these are some of the more kind of notable things we've seen over the past year or so. And in the next couple of slides, I'm going to look at how how these capabilities will be, how they can be incorporated into air-gapped environments. So when it comes to air-gapped, I think it's important. It's obviously important to talk about open models, right? So when I spoke about open models for the first time a couple of years ago, it was a very different picture to what we're seeing now. Back then, if you really wanted the best AI experience and the best generative AI performance, there was really no question about it. You needed to go with a proprietary model at the time. But even back then, what we saw was that these smaller models, when they're specialized at certain tasks, we saw that they were able to outperform these larger, more generalized models. And that's still very much true today. But 6 months is a long time in this space, let alone 2 years. And what we've seen over the last 6 to 12 months has been really a sea change in the capabilities of open models. So I want you to cast your mind back to maybe 6 months ago or so. I think it was back in February where DeepSeek R1 arrived on the scene and really turned the industry upside down. So I think everybody was shocked at that time, and it's single-handedly wiped out 600 billion off the market value of NVIDIA at the time. Suddenly everybody realized that the moat around these proprietary models, it really wasn't as deep as we thought it was. Now I could download a model like DeepSeek R1, and I could run it on my PC at home and get a ChatGPT-like experience, right? So that was really a game changer. And in the time since then, in just like 6 months, we've seen further advancements, incredible advancements in some of these open models. So there are a number of benchmarks out there, too many to mention, and they measure model performance. So you have things like SWE-bench, Human Eval, MMLU, lots more. And this screenshot here is from SWIBench. And what they're showing is that, and I'm going to take Qwen3 Coder as an example here. They're showing that these models, when they're married with the appropriate interface with the appropriate logic, their outputs are extraordinarily close to what we see with those from the proprietary models. So, the current generation of open models have come a long way, and right now they're also providing agentic capabilities as well. So things like reasoning, tool calling, support for larger context windows, 128K and above. And these are obviously all important ingredients for modern AI coding assistants and for agentic workflows. So all of this is to say is that there's never been a better time to host your own model, your own LLM inside an air-gapped environment and to deliver a cutting-edge experience to your engineering community, and more importantly, a secure experience. Now, another thing that I do want to touch on, and this is an important consideration as well when it comes to air-gapped versus cloud, and that is context. So as we all know, in AI, context is king, right? And one of the common mechanisms to pull in important context and provide it to an LLM is a technique or an approach called RAG, or Retrieval Augmented Generation. And I just want to take a moment to explain this for those who are not familiar with this this approach. So if you look at the diagram on the screen here, on the left-hand side, at the very top, you have the IDE or the agent or the CLI, whatever the client is. And then through this client, the user will ask a question of the assistant or the model. And there's a retriever that kicks in, and it performs a semantic search or a similarity search against a document repository. And this document repository is what's called a vector database. And it contains a representation of various, and I'm going to use the term loosely, documents from around your organization. And these documents can come in many forms. They could originate from actual code. So you may have Git repos, remote repos in your organization that could be many years old and contain maybe accredited software patterns for solving domain-specific problems. And these may be patterns that you want to surface as code suggestions for the developers. So that's a great, these code repos are a great source for context. But also anything that's related to the work that the developer is doing. So like Jira tickets, or any kind of document like a HLD, LLD, coding standards, system requirements, anything that's on Confluence or SharePoint. These are things that you'll want to connect to your coding assistant. And so what happens is there's a process that kicks off where all of this information is indexed into this vector database. And then, as I say, the retriever pulls out the necessary data or context from this database and provides it to the LLM along with the user's query or prompt. And of course, the idea then is that the model has everything it needs to be able to provide a correct and satisfactory response to the user. Now, this poses two challenges when it comes to cloud-based AI vendors. One is, to do this indexing, many vendors will require some sort of ingress into your network and into your source code management system or your document store. So that's obviously going to be problematic in some cases. Second of all, this vector database that's created, very often that is indexed and stored server-side with some of these cloud vendors. And so again, that's another potential attack surface or a breach point, and so something that you may not want if data sovereignty and data loss is something that is important to you or are concerns for you. So all of this I'll talk about now as we get into the implementation side of things, but you'll see, like with an air-gap deployment, how this becomes not only easier to implement, but also how it can be done in quite a safe manner. All right, so let's get into the practicalities then. So here you're looking at a typical air-gapped architecture for AI. And really, this is all about building data privacy and data sovereignty as foundational principles here. So the first thing to kind of point out is that it's a containerized deployment model, typically using Kubernetes orchestration. And very often there's a dedicated GPU cluster for the service. And this isn't just about using modern technologies here, but it's about ensuring that there's performance and scalability as demand kind of goes up and down. The GPU cluster is very often dedicated to the AI workloads, as I said. This ensures not only predictable performance for generative AI, but also complete isolation from other systems. So this is a privacy by design approach, and what it means is that the security isn't bolted on, but it's built from the ground up here. So we're implementing zero trust principles in here, where every component needs to be authorized before there's any interaction between them. All the data, of course, is encrypted at rest. Typically, it's encrypted in transit as well. I know we use TLS 1.3. And then, one of the key aspects here that's important to kind of, be mindful of is that there are no remote dependencies whatsoever. The system doesn't need to phone home. It doesn't need to check for licenses online, and there are no updates that need to be downloaded automatically. Nothing like that. This is all completely self-contained. Now, in the last slide, I spoke about context and RAG in particular. And this is where this architecture really shines. So as I said, like in many cloud Gen AI services, your organizational knowledge will get uploaded, indexed, and stored on an external server. And every query potentially exposes your IP. With this architecture, your code, your documents, your knowledge base, all of your IP, it stays internal. The indexing happens on your servers. The vector database runs in your environment, and the retrieval happens inside your network as well. So, your IP remains yours and your competitive advantage as well. Performance then is another aspect of this, and another reason to kind of go this way. Because you're in control of all the variables here, there's no throttling because there's no external service, right? There's also no rate limiting because you control the infrastructure. And if you need more capacity, you can just add more resources. So you're not competing with other customers for API quota or waiting in queues or anything like that. Observability is another thing that you'll notice in here as well. Again, you'll get comprehensive dashboards here around usage and operations. But the key thing again is there is zero external telemetry, which is really important. Even we as AI coding assistant vendors, we don't phone home. We don't even know if you're running the system unless you tell us, right? So this is completely self-contained. All right, so to summarize what we're looking at here, this is what a true architectural respect for your security perimeter looks like. It's data sovereignty with complete control of your data and complete privacy as well. Every prompt that your users enter, every response that's generated by the models, every piece of data that's processed, it all stays within your four walls. Okay, so how long does it take to get up and running with something like this? Well, what we're looking at here is typically a 2-week time frame. You can move quite quickly with this. And so the first kind of activity in the first couple of days is infrastructure validation and readiness. So, here we're either building from scratch, or if you already have the infrastructure, we can use that as well. So we're validating that the Kubernetes cluster is ready, the GPU nodes are properly configured, and that your compute meets the requirements. We also provide automated validation tools to check like storage performance, application performance, the network configurations, and so on. And by the end of this process, this first stage, we'll have confirmed that your environment is ready, or we'll have identified if there's anything that needs adjustment. Most organizations will pass this phase in about 48 hours, particularly where they already have an existing enterprise Kubernetes deployment or infrastructure. Then we move into the installation, the deployment, and here our team helps you with that, and installation is performed using Helm charts, and it typically takes roughly about 2 hours. It doesn't take long at all. The rest of this phase then is configuration, so setting up the storage backends, connecting to the GPU resources, database configurations, and so on. And by the end of this phase, the platform will be up and running, the models are loaded, and basic functionality is verified. Then we move into access and setup, and this involves setting up the various teams. And so if I speak from Tabnine experience, what we do is we create a group structure that reflects your organization. We'll also, in this phase, we'll connect to your identity provider. So if that's Active Directory, ADFS, or some other SAML-based IDP, we can do that integration in this stage, and we'll map your existing groups and roles into Tabnine teams and permissions, so that the RBAC is set up to match your organizational structure. In here as well, we'll also set up the compliance logging, the audit trails, so that they're ready to connect to your systems. Then we move on to Gen AI readiness, where we can set up the context engine. And so, again, this is RAG, and ingesting your code repositories, your documentation, your coding standards, and so on, and creating a searchable knowledge base that the model will use to understand your domain. And in here as well, we'll test the models against some of your use cases. And by the end of this, you'll have an AI platform that's working to your specific needs and that understands your domain. And then finally, we're at the point then where the developers are ready to come on board. And here the developers will install the plugin into their IDEs. So VS Code, IntelliJ, Eclipse, Visual Studio, you name it. And they start to authenticate and they start coding, right? And from speaking from experience, it's at this point as well that we typically would bring in a customer success manager to deliver training at this point and ensure that the users are enabled and that they can hit the ground running. So that's the 2-week time frame. And by the end of this, your developers are getting AI-powered code suggestions that are tailored to your specific domain, following your coding standards. And as I say, it's all secured, all the interactions stay within the boundaries of your environment. Quick word then on maintaining such a system. So the first thing to kind of really talk about is our update philosophy. So at Tabnine, we provide updates on a monthly basis, and these include new functionality, performance improvements, incremental enhancements, bug fixes, and so on. We then provide critical patches on a as needs basis. So there is no fixed schedule for patches, and so you get these security updates ASAP and when they matter. The updates are also possible with zero downtime, because we support rolling deployment strategies so that developers never lose access to the AI capabilities during maintenance. In terms of delivering these updates then, we're very flexible on the delivery mechanism. So for some ultra cautious organizations prefer physical media, so we can deliver updates on encrypted drives. But most commonly, we see organizations using a DMZ or a Bastion host as a means through which these updates can be transferred. So we support whatever method aligns with your security posture. Model updates as well is worth a mention here. As I mentioned before in the previous slides, this is a very fast-moving space, and there are new and improved models coming along all the time. And when they do, we can deliver them as signed encrypted packages. But the important thing here is that you get to control when you deploy these new models. If you want to test a new model in a sandbox before rolling it out to the engineering community, that's absolutely no problem. Or if you want to stay on your current model, maybe for compliance reasons, that's your choice as well. You're never forced into an update that might break existing compliance or workflows. We also support bring your own model. So you might already have an in-house model that you're using, something that's specialized for certain workflows, and you can certainly incorporate that into your air-gapped AI coding assistant as well, so it can run alongside some of the other models that are provided out of the box. The only stipulation that we would have is that these models provide some sort of open AI compatible API. And then finally, observability is important for ongoing maintenance. And so out of the box, we would ship with Prometheus because it's open source and it's robust. But we know and we've seen that enterprises have their own existing monitoring tools and infrastructure. So things like New Relic, Datadog, even bespoke elk stacks. So whatever it is that you're using, we can integrate that in as well, so that you have a single pane of glass for your entire Gen AI infrastructure. So you'll see all the metrics on CPU, memory, response times, error rates, you name it. So in short, the maintenance story here is it's actually better than cloud-based solutions in some cases. You have a lot more control, you've got better visibility, and everything is aligned with your change management processes and your security requirements, which is very important in some cases. Okay, so that brings me to the end, and if you'll allow me a few more seconds, I do want to kind of just say a few words about who we are and what we do. So, first of all, Tabnine is an AI software development platform. We've been around longer than most, and as part of this platform, you can see in this diagram many of the things that I've already touched on. So we provide support for all of the various models out there, both proprietary models and open models. We support all of the various languages and frameworks out there. We support more IDEs than anybody else. So VS Code, the entire JetBrains family, Eclipse, Visual Studio, you name it. We support them all. We support, we're also agnostic in terms of source code management systems as well. And so we provide support for the main Git-based SCMs and even Perforce when it comes to things like RAG and, connecting to your repos where you have a lot of your institutional code and knowledge, as part of that whole RAG mechanism. So we provide support for all the major SCMs. In the middle there, the blue box is the enterprise context engine. So, I touched on this earlier on, the importance of being able to bring in all of that deep organizational knowledge and all that institutional knowledge in whatever form it may exist into your coding assistant and provide that very valuable information to the model. So that's something that really underpins our platform and something that we've been called out for by the likes of Gartner. And then at the very bottom there, you can see all of the various agents that we provide out of the box, all these various agentic workflows for various SDLC activities. So that's a Tabnine very quickly. And again, I mentioned Gartner just a couple of weeks ago. They've named us as a visionary in the category of AI coding assistants and #1 in a number of capabilities. And I think this slide here really just kind of encapsulates who we are. So it's like we can deploy anywhere. If you want to use Tabnine as a public SaaS service or as a private SaaS service, that's possible. Or if you want to go on-premise or indeed air-gapped, which is the topic of today's discussion, that is very much possible with us as well. We have that. We provide that deep contextual awareness as part of the product and as part of the interactions that your developers will enjoy. Tabnine is also very steerable, as we say, which means that you can provide the rules and the guidelines by which these code suggestions are provided to developers, both at inference time and also after the fact as part of automated code reviews. It's flexible, as I mentioned before. We'll support any LLMs, any IDEs. And finally, it's what we call governed. So we provide all of these enterprise governance features as well. So audit logs, access controls, RBAC, and also you can even have inference time protection. So if you want to see where these code suggestions are originating from which repos, open source repos, so that you can provide attribution in your own projects, or indeed, if you just want to block those suggestions as well, that's something that we provide as part of governance in the product as well. So that's a little bit about Tabnine, who we are, and I hope that what I've discussed over the last 45 minutes now or so has been of interest to you. I hope you've learned a thing or two that you didn't know before. And if anything here has really piqued your interest, or if you want to continue the conversation on any of these topics, please do reach out to us. You can contact us at tabnine.com. We'd be more than happy to pick up this conversation with you and dig a bit deeper into some of these topics if you'd like, and even go so far as to set up a pilot with you if you want to go that far. So thank you again all for your time. I hope you found this informative. And what I'll do now is, with 15 minutes or so left, I'll move on to Q&A if anybody has any questions at this point.
If you're on our streaming platform, you can type your questions in there at the bottom. Otherwise, we are monitoring LinkedIn as well. I have a few questions coming in, John. First of all, thank you. That was fantastic. Exactly what we needed to hear as it relates to air-gapped deployments. Some questions are similar, so I'll paraphrase a few of them. But what are the minimum hardware configuration requirements here? What are the GPU requirements in general? Talk to me about hardware.
Yeah, so it's really dependent on the model that you decide to go with. So obviously, all of these models, these open models, come with different numbers of parameters and different weights and sizes. I would say that probably the more intensive of the models might be Qwen 3 Coder at this moment in time. And with that, we do recommend H100s to power that model. And it really depends on the number of users as well, and the kind of latency that you're looking to achieve in terms of generative AI performance. Typically, what we would recommend is maybe kind of just start with maybe 2 GPUs, maybe 2 to 4 GPUs to start with, and then as you bring on more users, you can then kind of start to scale that up accordingly.
It's related to another question here. I want to limit some teams to some LLMs and use better models for others. Can I mix and match with this?
Absolutely, yeah. So there is this concept in Tabnine, for example, of teams where, and on a per team basis, you can specify which models are available to those teams and the users within those teams. So absolutely, that is something that can be done, yeah.
Well, and that's a way, if I'm hearing this right, that might be a way to maximize some of your hardware requirement issues, right? If you've got lighter weight models that are a little less intensive and they have the right job for those, use those. And
exactly.
Then your models. You don't need to peg the procs all the time, right? You can
exactly, yeah. So you're not going to have like GPU sitting idle, right? Just basically use what you have as you need. Maximize the use of your GPUs and then make those correct models available to the correct teams. Yeah,
super efficient. Yeah. What are the ongoing maintenance support costs? That's a point blank question. Yeah.
Yeah. So, well, speaking from a Tabnine point of view, there is a flat monthly fee on a per user basis. So I think if you look at the pricing page on the Tabnine website, you'll see that for enterprise, it's $39 per user per month. And so that's the license, which includes updates, maintenance, and includes 24/7 support as well. So everything is included in there. It's a flat fee. And that's kind of that's a nice assurance to have as well for a lot of enterprises.
Yeah, the Tabnine cost side of this is predictable. It's a flat fee. You don't have to
100%.
worry about that. You've got your budgets locked. You can calculate this on the back of a napkin. Count
Yeah,
heads.
exactly. And for the duration of your subscription, you'll get those patch updates, those monthly updates as well with new functionality and new models as and when they become available. And once we've tested them, and we feel that this is something that's going to like provide a next level experience for our customers, you'll get those as well.
Yeah, absolutely. Yeah. And often we'll use this office hours space to announce those and to tell you how to use them.
100%. Yeah.
Yeah. So the short answer is there is no ongoing maintenance, and you get to pick. Like there was one of your slides, John, where you detailed you can pick which updates you use, and you can wait. You can use what's right for your organization. So we're not pushing anything down a pipe to you.
Yeah, exactly.
Great. What is the token consumption like? You mentioned millions of tokens, and I think that might have scared some folks.
Yeah, so it's really it's quite a the answer to that is really quite variable, and it depends a lot on it really depends a lot on the kind of work that you're doing. If you're doing something fairly trivial, then I think you could consume as little as 1 to 5,000 tokens as part of your work, right? But if you're getting into more intensive type of work, if you're working with large documents, if the agent is retrying a lot to solve a problem, there are all these factors that come into play. I mean, personally, I've seen when I've kind of in a typical session for me, I might go through, and these would be short sessions. I might go through 200 to 300,000 tokens on a fairly moderate change. But you could have some people who are like coding all day and they're working intensively, and the agent is working in a fairly autonomous fashion and maybe refining some of its work. I mean, you can get into the millions. So it really is how long is a piece of string. It's really hard to kind of
well, one of the things I love about our context engine is that with better context comes better results, right? You don't need as many round trips. You don't necessarily need, it's more efficient at the end of the day. So it's a better quality result if it's more contextually aware, if it fits what you're trying to do the first time. You're less likely to have to round trip. We've all done that many times where we push
absolutely. If you can, context is everything. If you can provide all the required info and instruction the first time around, then you're going to get what you're looking for first time, right? So yeah, agreed, 100%.
It's a fun one. We use COBOL. What languages do you support?
You use COBOL. Okay, well, so again, all of these modern models, they support all of the major languages, and COBOL is one of those. So they may not have seen as many open source examples of COBOL as they've seen with other languages like JavaScript or Java, for example, but these models know how to code in COBOL, and so these models will support COBOL for sure. And again, if you want to connect additional context, like if you have existing COBOL code that can serve as inspiration or context, that's only going to help as well.
Yeah, and there are no language limitations from Tabnine's perspective.
No,
like
none whatsoever.
The LLMs all know what COBOL is. So the good news is that the context engine works with pretty much any language we can think of.
Exactly.
So that there's no limitation there. Yeah, that's great. Let me see. Some questions are coming in. Ooh, this is a good one for you, John. How do you see architectures evolving over time?
How do I see?
I think they're asking about the AI space in general, but you talked about last year, you talked about this year. What's changing from a hardware perspective, from an architecture perspective? Are there anything emerging that you think about? I'm guessing.
Well, if I take that question at face value, architecturally, and given that we're talking about air-gapped, I don't see anything fundamentally changing in the near future when it comes to air-gapped architectures. I think a lot of this stuff is non-negotiable. Data cannot enter or leave the perimeter for a lot of enterprises, a lot of organizations. So I really don't see a lot of change really in that regard. I don't know if the question pertains to something else, whether it's models, but
yeah, I think they were just leaning on your. I'm guessing here, leaning on your experience as an architect, just seeing what what you're thinking.
Yeah, so as I say, I don't really see anything fundamentally kind of changing really outside of the models themselves. I think the biggest concern that we have right now is tooling and MCP, for example. So these models, these agents are now able to, they're able to do so much and take away a lot of that kind of menial work away from us. They can check in code on our behalf. They can create a pull request or a merge request on our behalf. They can submit a change request.
And all of that can be automated, which is the great thing, right?
Exactly. But, as I said at the outset, all of this introduces risk as well. And so, I think maybe one thing that I see changing, and maybe where a lot of work is going to focus, is around governance of tooling and MCP. I mean, if AI performs some operation and it's using my credentials, was it AI that performed the act, or was it actually me that performed the act? Where do we draw that line between AI acting on my behalf and me actually doing that thing? So I think governance is going to be an important focus point over the next few months and next year, I guess.
We think about that a lot at Tabnine. We've got a lot of features both in the roadmap and coming out soon that are governance related.
Yeah.
And really important to understand not just predictability or who broke the build or whatever it is, but the full gamut of visibility and control over what your teams are doing. Time for a couple more questions here. Here's a good one. What's the one thing you wish security or compliance teams understood better about AI?
What do I wish that they understood better about AI? Well, I think security teams and compliance teams are understandably cautious about AI. Maybe you could argue overly cautious. Although I would say cautious with good reason. I think I think that security teams, I mean, it really depends on which vertical you're operating, which, the type of enterprise that you belong to. I mean, if, financial services, for example, is a very risk adverse sector, and many organizations within that, they're continuously thinking about security and control, and very, very often controls are more important than speed, right? Speed is secondary to control. So it's hard to kind of change that mindset because of some of the dynamics at play. But I think that what I would like to change in the mindset of somebody from security or compliance is that, AI will help them. They've got to see that AI can help them with security and compliance by automating many of those checks and balances and controls that exist today.
Yeah.
Even with, regardless of whether the code that's trying to make its way into production was human created or AI generated, you still have to do code review, right? That's a non-negotiable thing and a very important activity, but AI can help with that as well. So for example, in Tabnine, we allow you to put in place code review rules and upload coding standards and have the coding assistant perform automated code review. And you can have this as a kind of a pre-review before it gets to the human code reviewers. And what this ultimately does is it lessens the load on the human code reviewers who are already busy reviewing human created code, right? Yeah. So I think, to answer the question, I would say that the one thing what I wish they would see differently about AI is that it can be used to help them and to help their colleagues greatly.
Absolutely. And it's quantifiable. Like you can see that your more code is passing. You can see that the policies are enforced. You can literally count them. Yeah. I see the other side of this. I'll go ahead and cheat and answer this myself too. The thing that I see is shadow IT, the old specter of shadow IT, right? If you're not providing a great AI coding experience, they're going to use their own, and they're going to cut and paste. And that's many teams. We see that in the industry all the time. So if you don't have a solution for that air gap situation where they're locked in, they're just going to be a risk, and they're going to try and solve the problem other ways. They're devs. That's what we're going to do. I think we're running out of time. I think that's right at the top of the hour there.
Okay.
John, anything else you want to add while you have folks' attention?
No. I just want to reiterate. There's been a lot of ground covered, I think, over the last hour or so. Again, if there's maybe some folks have questions swirling around in their minds, or maybe something wasn't clear, and if that's the case, again, just reach out to us. We're here. We love to chat with you. So don't be afraid.
Good point. So not only on our website, but also Duncan at tabnine.com. You can just reach out to me. We're here to help. We're here to help evaluate what your team is doing and how maybe we can help you solve some of these tough problems. Office hours will be back. We are doing an update on some features soon, and another demo just after that. So subscribe to the YouTube channel if you haven't. Tabnine's YouTube channel is great, and it has a beautiful backlog of wonderful things that you can view and find out how to use this in your organization. Thanks, everybody.
Okay. Bye, everybody.